For this question, it says a car of mass 1,200 kilogram is connected by a tow rope to a truck of mass 2,800 kilograms. So we can write that down straight away. 1,200 kilograms and 2,800 kilograms. The truck tows the car in the straight line along a horizontal road. Assume that the tow rope is horizontal, so we can just ignore that. A horizontal driving force. So it says driving force, so it goes in the direction of whatever these vehicles are moving, of 3,000 newtons acts on the truck. So the truck is clearly going this way, and it says driving force, so it's 3,000 newtons. A horizontal resistance force, so it goes the opposite way basically, acts of magnitude 800 newtons acts on the car. So it's like this, 800 newtons. The car and truck accelerate at 0.4 meters per second. So this diagram clearly shows the van and car going this way, so we know the acceleration is also going that way, so we can write that down. Right, so we can break this down. Car is 12,000 kilograms, we'll just do the car for now, and 800 newtons, and we know this is the tension. Since we're finding the tension, T is equal to each other, but they're in opposite directions, so we'll break it down here, and we'll just use the car for this example. So we know that the acceleration is 0.4 meters per second squared. So we know that the tension is going in the same direction as the acceleration, as they're both pointing this way. So that means if they're both pointing the same way, if acceleration is positive, that means the tension is also positive because they are pointing the same way. T. So what is the force that is going opposite that? That is 800 newtons here minus 800 newtons, which equals another force, but we don't have another force. We only have the mass left and the acceleration left. So ma, but what do we know? F equals ma. The force equals mass times acceleration. So T minus 800 equals F. So in other words, T minus 800 equals 1,200 times 0.4. So T minus 800 equals 1,200 times 0.4, which equals 480. So T equals 480 plus 800, which equals, so T therefore equals 1,280 newtons. If you're missing the acceleration, then you would also need to use this, the truck, and make T equal to each other, and you should be able to find it. Right, B. Show the magnitude of the horizontal resistance force acting on a truck is 600 newtons. Okay, this is a show that question, so we can do that quite easily. Since it's the whole truck, we can, the magnitude of the horizontal resistance force, so the magnitude, we can talk about the diagram as a whole. So M in total equals the car, 1,200 kilograms, plus the truck, 2,800 kilograms, which equals 4,000 kilograms. And A, of course, is constant, which is 0.4 meters per second squared. And obviously the resistive force in the opposite direction is 800. So in this question, in this part, T is negative because it's going in the opposite direction of the acceleration. If this is the positive direction, this is the opposite. So therefore that means T minus. Hopefully that makes sense. So minus T, and we need another force. So this is going in the same direction as the acceleration. So this is a positive force. So plus 3,000. But since we're working on it as a whole, this is a resistive force as it's going in the opposite direction of the acceleration. So therefore that would be minus 800 equals MA, and we know that we need it as a force, so F equals MA. So F equals 4,000 times 0.4. That equals 1,600 newtons. And notice how all of these are in newtons and all of these are in newtons as well. So that should help. Right, 1,600 newtons. So let's write this in a nicer way. So 3,000 minus 800 is 2,200. So 2,200 minus T equals 1,600. Right, so here we can rearrange it. Hopefully you know what to do here. So we can say 1,600 minus this, and we can make that plus, as tension is minus right now. So that would be changing its symbols, so 1,600. So if that is minus, that would now turn into plus. So that would be minus 600, 1,600 plus 2,200, which equals 600 newtons. And that's what, and since it's a show that question, we know it's right, we get those full marks. In the fact that the rope is not horizontal, assume that the air resistance of the force and the driving forces are unchanged. Is the tension in the rope greater or less than in part A? Well, if we think about it, it increases because there is more tension or greater tension. So there would be, so the horizontal component would be the same as the tension above. So we can say for C, it's greater, it is greater tension because the horizontal component is the same has the tension. That should give you the mark. Hopefully that makes sense.